Okay, so welcome back. In the previous page, we have mentioned how to construct a KD tree in a high-level language, and we also provide with an example. In this page, we want to show you the algorithm we can use to construct a KD tree, which can serve as a multi-dimensional index. So according to the algorithm, we need to have some inputs. The first input we have here is a P. This P denotes a region actually, and another parameter we have is called depth. As you can see for the algorithm, this algorithm will be based on a recursive calling, right? This is a recursive algorithm. It really depends on the region, right? If the region has only one single point, we will return it, right? Otherwise, we can further split the region into two parts, right? Okay, so let's take a look at how this algorithm works. So according to the algorithm, the first clause we have here is if P contains only one single point. In other words, this P, this region or this space contains one single point, this one single data point, right? Then we can construct a leaf node, right, storing this data point. Okay, so this is one condition, right? If this P contains one single point, then we can do this operation. Otherwise, here we have this else. This else corresponds to this if, right? Else, if the depth is even. In other words, we have even depth. If so, then we can split this space or this region according to the x coordinates, and we can draw one vertical line through the median x coordinate into two regions P1 and P2. This P1 corresponds to the left region of the L1, and P2 denotes the right region of L1. Here we need to pay attention here. We use this splitting criteria with this median coordinates of the x, right? In other words, we can ensure, all the data points, half of them will be in the left-hand side and half of them will be on the right-hand side. And we decided we split according to either the x or y axis or coordinates depending on the depth of the tree structure. If the tree structure depth is even, it is starting from 0, right? If its tree structure depth is even, then we split it according to the x-axis. Else, this else corresponds to this if, right? If this depth is even, then we can do this operation. Otherwise, if the depth is odd, then we can do this operation instead. In other words, we can split according to the y-axis, and we can split the P region with a horizontal line L through the median y coordinates into P1 and P2 as well. And here we also use this median, right, y coordinate. We can ensure half the points will be above the line and half will be below. So depending on the depth of the tree we are line for the region, we can split this region into two parts according to the x and y coordinates. And then we have P1 and P2, right? And there are two regions. So according to P1 and P2, we can further build a KD tree by recursive calling this function again, right? So we can call this build a KD tree, this function again with P1 as the inputs, and we also increase the depth of the tree plus 1, right? It will be similar. We can also build another KD tree according to P2, right? And we also increase this depth. And we can use this to KD tree returned by these two functions as the left children nodes and the right children nodes. And here we can further create a node V storing the 9, right? Which will be the internal nodes. And we can make the left children nodes and right children nodes as attached to this V, this node. And we can also further return this V as the return result for the function call for this layer or for this depth. Alright, so this is about KD tree construction algorithm. You can see this tree will be constructed recursively from the root until all the nodes in the leaf nodes, they have only one single data point in the region. Okay, so this is about the algorithm, and you can take a look at this algorithm by yourself. And if you want to have a try, you can write this algorithm by yourself in some programming language to test it.